So, welcome to episode 2 of the BotPod in our Lawrence Harvey Tech Talk series. Today, I am being joined by Mads, a technology leader with over 20 years of experience in robotics, AI, and product innovation, previously holding leadership positions with globally recognized names like Mobile Industrial Robots, Apple, and Autodesk. So, Mads, thank you so much for joining today. How are you?
Thank you. Very good. Thank you. Thanks for having me. It's a pleasure being here.
Awesome. So I appreciate I've given a little bit of background intro to you already, but tell me a bit about yourself, your background, and maybe why we're chatting today.
Yeah, thank you. Absolutely. My background is in robotics. I have a degree in robotics, and I've kind of been in and around robotics for, yeah, as you mentioned, 20 years. I think my passion for technology and robotics in particular have taken me around the world, being Danish by birth. I obviously grew up in Denmark, worked for Danish technology companies and the Danish university for a while, and then spent time in Asia, specifically in Singapore with Autodesk, building software for all kinds of engineering applications. And then also about 10 years in the Bay Area working for technology companies that you mentioned, always in and around industrial software for manufacturing purposes, control, geometry, robotics, and those kind of things. I most recently moved back to Europe a couple of years ago, back to Denmark, where I have worked for among other companies, Mobile Industrial Robots, running the R&D organization and building full stack robotics, everything from hardware, electronics, navigation systems on robot software and cloud deployed fleet solutions. So that's really full circle for me, both in terms of geography and technology stack.
Awesome. And do you think that kind of massive geographical, but also, I guess, ideological difference in terms of how robotics are built and developed and thought about, has that kind of really changed how you work as an individual from working across Europe, the Bay Area, to like APAC regions and teams as well?
I certainly think there are differences kind of in the approach that's taken in, let's say, the Western world, the Western approach, and what I've seen in Asia in general, specifically over the last couple of years, where I've been seeing a massive acceleration of interest and means and funds poured into the robotics industry as a whole. So certainly the availability of human labor in Asia sets them on a different trajectory compared to the European and US approach, where replacing, or not really replacing human labor, but really making up for a deficit in available human labor, is more the direction the robotics industry is taking.
Interesting. And something I actually touched on a separate podcast is, the aging population, the
Yeah.
changes in like the labor workforce, not just in Europe, but of course, around the world. So great that you touch on that too. And yeah, today we'll really be kind of diving into this like sudden acceleration of what we're seeing in like the robotics industry, not just in Europe, but pretty globally, I guess. So, I think we've spoken previously that some people talk about breakthroughs as if they're still like decades away, but how we kind of said it was the last 8 months have felt like 20 years and fast forwards almost. Like it's really fast, it's really exciting, and it raises all those questions. So I guess today we're really unpacking what's happening in robotics, why it matters. So, who's building them, how they're being built, and where we're actually going to, I guess, see them in the real world, right?
Yeah, I think we are not too far off now. And as you mentioned, I've been in the industry for about 20 years now. And again, coming out of a robotics background, it's safe to say that I can probably call myself a classic roboticist by now, right? That it's all built around, let's say, how we build robots up until I want to say, I think I mentioned 8 months to you, but in the last, say, a year maybe, things have fundamentally changed, and I'm actually looking back on my career in robotics, and I think more things have happened in the last year than in the previous 19 years, right? Like back then, as in the old days, 1 year ago, we were talking classical control theory things, of course, not how we did it 20 years ago, but still kind of mathematically modeling our robotic system and creating computer vision algorithms that could help in very specific applications, feedback laws and kinematical models and all of that stuff. Very, very tedious, very hard to tune and make work. And this is probably also why we've always seen robotic applications kind of in well-controlled environments, manufacturing and industrial applications come to mind. And maybe a couple of years ago, a lot of research poured into reinforcement learning and more learning-based approaches, where a lot of simulation tools were used to train, skipping the whole kinematical model and control system, and really train policies that allow robots to perform much more complicated applications. But that approach have really shown to be hard to transfer to the real world, right? Like they perform well in simulation, they perform well under, let's say, these ideal environments that you have in simulation, but taking them out of that and putting them in the real world, especially in applications where determinism is required, where you can have robots do things that would really mess up a production line. I think it's fairly safe to say they haven't really taken off in the way that we in the robotics world had hoped. And then recently, a lot of time and data and GPU time in particular is poured into vision language action models and more imitation learning and mimicking behaviors of human beings. And I'm very, very fascinated about those approaches. I think those approaches have a fundamental potential of opening up a brand new field of robotic applications where maybe takt time and determinism and specific performance linked to, say, a very mathematically correct trajectory of a robotic arm, for instance, is required. And so there's a whole category of tasks that you wouldn't automate today, say packing boxes of different items or picking from shelves and those kind of things, simply because it's too hard to describe the mathematics to do it. But now if a robot can learn from simply imitating and mimicking a human puppet master, if I can call it that, we're looking into really democratizing robotic applications, and where it doesn't take a roboticist to really set up the whole work cell and describe the mathematics and all of that. And that is very, very fascinating to me. And I think we're right there at the inflection point where we'll see some of it. And we talk about a lot of money being poured into investments in humanoid robotics and that, and one can think of humanoid robots whatever way he or she wants, but certainly the foundation research being put into that field would also have the potential to benefit this new maybe lower hanging fruit in industry. So I'm very excited about what's going to happen for the next couple of years, or maybe even shorter time. I think I'm constantly surprised at how fast things are moving these days.
Oh, definitely. And you touch on some quite a few, but some really important points there that will definitely follow on through this chat today. But things from, like simulation data and imitation learning of, we can simulate things as many times we like, but you put that into an unstructured environment and like, what's really going to happen and how do we kind of manage that? So it's that interesting balance of, imitation to reinforcement learning. But yeah, you mentioned so many great points, like the data, being king and the massive GPU compute level that we kind of need to get this data structured for various simulations. So I guess kind of with that, like let's start with this breakthrough, right? So we're talking about over this past 8 months, year or so. And you touched on a few points. So is there anything specific in terms of the changes in robotics that have like blown you away almost? Like I'm talking about the stuff that felt like super impossible a year ago, whether it's certain vision or language action models that have been implemented, or what are you kind of really seeing that's gone, oh my God, this is massive?
So I think I'm not entirely sure I want to highlight a single thing, but rather maybe maybe I can flip the question a little bit around. But you correct my course if I'm not going in the right direction.
Go for it.
But I think there's a lot of I don't want to call it noise now, but certainly there's a lot of results coming out from a lot of new companies that are working with these technologies. Whether they're in the humanoid space or in dual arm torso style robots in manufacturing lines, or mobile robots, or those kind of things. And I think I have a hard time, as I envision other people have, to figuring out what's noise and what are real results, right? I think there's a very, very big difference between seeing a humanoid doing breakdancing and backflips and having a humanoid actually perform tasks in an industrial setting, under the safety requirements that's in a factory floor, not competing with, but basically performing to the same level as a human worker would do. That doesn't mean it's not impressive that humanoids can do backflips. I can't, so already they're ahead of me. But I'm really hoping that we'll soon see some actual end of line industrial or real life application of these technologies. I think it's about time that we kind of put these technologies to the test, and try and see if we can bridge that gap to the more classical industrial robotic solutions that's being deployed in industry today. The reason I don't want to really highlight anything in particular, I know there are several companies that are working in this space, but I don't think we have yet gotten to a point where these imitation learning models, VLAs, maybe even based on reinforcement learning, are actually deployed the way that we see in, let's say, academia and research-focused companies. So we are right there, but I haven't spoken to any customers that have purchased such a system and have put it into production and said, yeah, this actually performs just as well or even better than my, let's say, system of yesterday.
No, really interesting. I guess it's that cusp piece that we're all on, waiting to take that step over the line, right?
Exactly. I kind of want to, and it's one thing is like being the company that develops something, or the roboticists that build it, right? But the real, let's say, checked box is the customer saying, this, I actually have it in production, it's working 24/7, and I can program it, I can change my production line. 1 week I can package up dog food, and next week I can pack it up, I don't know, meat products, or whatever you want to put in boxes, right? Like that reconfigurability, I think is the determining factor here for these new kinds of applications.
Definitely. And I guess with that, is it like I guess for me, I want to ask, like, why now? Like, is it because this masses of like simulation data that is available, and this masses of training that people are putting through in the R&D phase of like, why now? But yeah, like, what do you see as?
Yeah, I think I don't think it's difficult to really figure out why now. I think a lot of technologies have come together, or have kind of arrived on stage at the same time, right? Like, obviously there's been a huge push in both hardware and software and frameworks for machine learning, right? Like, you can hardly open any news site around technology and not see NVIDIA and a lot of other big tech companies investing huge amounts of money into developing technology and GPUs and accelerated silicon that allows us to run these kind of payloads in real time. I mean, machine learning and AI is really nothing new, right? It has been around for decades, but we have only recently come to a point where it makes sense to try and train models that have so many parameters that they would produce a result that could be deployed in the real world, right? And so, 10 years ago, we would not be able to train models with like billions of parameters, and hence not be able to make a robot do anything meaningful. And so that's one thing, right? And then, it's really interesting. I think, also something like ChatGPT and LLMs for more, let's say, non-robotic applications have opened the minds of the robotics community to say, okay, there's actually something here, right? But of course, robot applications and roboticists run into the problem that there's not a lot of robotic data available, right? Like something like ChatGPT is pretty much trained on the entire internet, but there is no giant trove of robotic data to train, industrial robots or mobile robots on. So that's where the that's where the push for more realistic simulation comes from, right? Like instead of having to go to an actual deployment and maybe record 24 hours of data, you can now simulate years of data in a I wouldn't say in a split second, but you can definitely do it in reasonable time. But then we're back with the how well does this generalize? And I think that's exactly the point, right? Like how well does this actually transfer to real applications that can generate revenue for robotics companies? Because right now a lot of companies are burning through a lot of money training these models, right? And at one point in time, those dollars or pounds or euros have to be paid back in revenue.
100%. And I guess with that, like you kind of called yourself a bit of a classical roboticist. You've worked in some pretty established like names and players, right? So for companies that have been in robotics for decades and are seen as these like not necessarily old school, but classical roboticists and classical robotic build out teams, how do you see them as like dealing with this like pace of change at the moment?
I think if you have an established customer base today and are selling product, you are kind of caught in a little bit of a limbo or a pickle between having to service that customer base and deploy into projects that have a target date and must be operational by some timeline. And you probably find yourself in a difficult situation where you have to balance resources between costing down your existing products, supporting these, let's call them classical deployments, yet not lose out on the opportunities that's bound to come in the next couple of years, right? And so it's a difficult position to be in, especially because, to my best knowledge, a number of robotic companies are struggling just due to market conditions, etc. At the moment, it's not easy to really be profitable in the robotics market at the moment. So it's a very difficult situation to be in, and I don't have the insights to a lot of the companies here knowing what their strategy will be, but it will be interesting to see in a couple of years, who managed to kind of cling on and work through this and build new technology, because like I'm not in all in doubt that there will be a lot of innovation and there will be a lot of new interesting ways of doing things, and it will be very interesting to see who will come out on top at the end.
Definitely. And I think it's the good definition of between a rock and a hard place, right? And it's finding that sweet spot.
I guess so. Yeah. It's certainly something that requires strategic thinking and setting a vision and a direction for those companies and figuring out, do you want to be a component provider? Say, a company, I only want to sell the arms or the mobile bases or the integration points. Do I want to move higher up in the application space where I start having sensor feedback and the ability to react to the environment? Do I want to provide full-blown solutions? Do I basically want my robotics company to be both the manufacturer of hardware, software, and deployments, or do I simply want to provide the software? I don't think we've seen a lot of pure software companies really succeeding very well in the robotics space, because so much is tied to the deployment, where there's this play between the hardware and the software. And so I think a lot of things are shaking up. And when you then throw in that it's not enough to really know the good old motion planners anymore, that there's a whole new way of doing things. It's like not only is it a difficult place to be, somebody also threw a grenade in there. So it's a really fascinating place to be at the moment.
Definitely. I think that's before you then think, and then the cost of the hardware and then shipping it and where are you purchasing it from and the reliability and the capacity of it all. So it's a really interesting point you make there. And I think we touched upon like the past year or the past 8 months, but if we then flip that and look ahead, let's go 12, 24 months, like what shifts or those like points of cusp are we on the horizon of that are really gonna not just change this like robotics evolution, but enable teams to like really, as you said, put this into production, make this, a productionizable, scalable, sellable product that's going to return strong ROI for like investors that are coming into this space too.
Yeah, I mean, I wish I knew. I wish I had like some kind of divine insight of this is exactly what's going to happen, right? But I have hopes for the industry, and maybe also kind of just a slight belief that that can happen. I think a lot of the robots that we see in the market today are obviously very well engineered, very professionally built devices with a high level of systems integration, right? Like we kind of have been building robots the same way for maybe 20 years, 30 years, of course, kind of refining and evolving the product, but fundamentally it's pretty much the same. And just because robots have been deployed in applications that require very, very high speed, very high repeatability, and very high accuracy, it just tends to become very expensive devices, right? Like the gearbox has to be very, very, very finely tuned, and the grease has to be the right thing, and all of a sudden you have a very expensive device, which also prevents robots from being deployed into applications, where the return on investment doesn't warrant kind of an investment. So I'm really hoping that a lot of these new control schemes, imitation learning or whatever it ends up being, can enable cheaper, less accurate hardware and kind of commoditize the whole robotics hardware business, and a better systems integration between the control software and the hardware itself can really make up for this. And whether it's possible, who will get there first, I don't know yet, unfortunately. But I think that thought is interesting because it would enable many, many more types of robotic applications, where the arm itself isn't such a big arm or mobile base isn't such a big financial, let's say, hindrance.
And I think if we all had that divine insight into, who was next, and if we knew that, we'd all be pumping our own cash into it, right? We wouldn't be having
We'd probably
conversations like
be
these.
hard at work building something right now. Yeah.
Cool. And so I guess you kind of touched on it there that, a lot has changed in like the design side, but also, over more recent times, the past few months, I've seen like articles and people speaking about the changes in costs of hardware, whether it's certain actuators and rotors and things like that. So have you seen any specific changes in like whether it's the design or cost that's making adoption more like realistic and practical, or like actually translates into robots people can use today for varied applications? You mentioned it's like automating packing for dog food one week and then another packaging automation function another week.
So I wouldn't say I've seen, I see the constant evolution of hardware and electronics, and there's obviously also new developments in the sensor space and new types of data modalities popping up that can be used for new applications. I think what's really interesting here and what could drive down cost is simply the economy of scale, right? Like there seems to be many, many more people working in and around robotics these days, and much higher demand for both different types of robots, and also just the sheer interest and amount of money put into, again, humanoids. I think drive a production scale that we haven't seen before, except for a few of the very large manufacturers that are obviously very professional in that. And a lot of I would say any robotic hardware startup always struggle to scale and get past that point where robots are built as, I wouldn't say bespoke devices for a specific customer, but certainly small scale production, and then taking the leap over to a fully, sometimes even automate robot building robots kind of production, right? And but with robots being commoditized or applicable in a much broader area of applications, hopefully cost will come down through just scale. So
Yeah,
I'm
no,
hoping for that, but I don't. Again, I would hope actually that the software progress in software control and the interplay between hardware and software and the learning-based control schemes can lower the requirements on the hardware, hence give us cheaper devices. But we'll see.
And that's, I guess, kind of why I fell in love with robotics. Like, came from a software recruitment background where I was, working with back-end developers day in, day out. I never saw the outcome. But you step into robotics and it's hardware, software, AI integration, and that kind of amalgamation of all of it is kind of what I fell in love with
Yeah,
anyway.
yeah, me
But
too.
obviously you've spoken there about like, there's still so many limits to this, right? So especially if we're talking about everyday work on mass scale. So is it more the capacity of, massive simulated data that we don't have yet that's affecting this mass scale? Do you think it's more so on the hardware side? Like, I guess let's like dig into reliability, cost versus versatility is like a three-way argument.
Yeah, I mean, so certainly, I think actually there are different domains and different types of robotics needed. I know, it's funny kind of watching what's happening in the space right now. There are almost like two camps. There are those that are like, yeah, humanoids are going to come in. They're the perfect replication of the human body. They can do the same things we can. And since the world is built for humans, there'll be almost like a plug and play solution for whatever automation we want, right? And then there's the other camp where I probably belong, probably given my background, right? That's a little bit more, I wouldn't say uh, less optimistic about humanoids, because I am optimistic about it, but I'm not convinced that they will be the ideal solution for all applications, right? And so I think we'll see kind of a trickle down effect of a lot of the more modern control schemes and imitation learning VLAs to a broad range of robotics. And so I think someone called it a Cambrian explosion of new robot types, right? And I'm in that camp. In a factory floor, wheeled robots are just faster and better and can carry more than a humanoid. And if you do need workers at an assembly line, why would you pay for legs for a humanoid, right? Like it doesn't have to go to lunch. It should be working, right? And so I think there's a really cool thing about to happen here, that hopefully we'll be able to raise kind of the, let's say, the shared platform layer of deploying robots to a higher level, so it's easier to build custom robots for specific applications, but leverage, let's say, a shared foundation. And all the efforts put into humanoids today and the VLA models and deep learning based control schemes, I think are helping raising that lower level or the bar a bit. So
Mm.
I'm excited.
And I can't help but agree with you there. Like, I've spoken to teams where I've worked with teams who are building kind of both sides of it. They're building with 2 feet for household applications. They can
Yeah,
climb stairs, whatever it may be, but they're also
absolutely.
building
And
a
yeah,
wheeled base. Like, why
totally.
spend that much money on, and like the focus on getting stable feet if you don't actually need them, right? It's just money for money's sake, and
Yeah,
money that we
I
don't
think
really
so.
have in
I
this
think
economic
so.
situation, especially in Europe, right?
Yeah, no, I think so. And it's like for let's say completely chaotic environments like households and homes with kids and those kind of things, that definitely this makes sense, right? Like building a robot that can climb stairs and wash windows and take care of cleaning up after kids. A humanoid probably perfectly suited there. But again, the funny thing is, like, factory floors are actually kind of designed in a certain way that's not necessarily mimicking let's say the human world that we live in, our homes, the cityscapes and those kind of things. So in those cases, I think there are robots that are better suited. But a lot of the technologies that could end up being the same, and it's just really the physical manifestation that's different. Right? So
Mm. I definitely agree. And
yeah,
with like the changes in like industrial automation and warehouses, it's probably going to be a case that the warehouse is built for the capacity of a wheeled robot in terms of size, space, scope. So it
yeah.
doesn't, where we have stairs now, like it's probably cheaper to knock the warehouse down, build a flat
Well,
one, and
in
put
some
a wheeled
cases,
robot in
yes, yes,
sometimes.
yeah. Sometimes there's a lot of retrofitting happening and using old warehouses though. So I think there's always. I think you're right. Like in some cases, there are the built for automation, lights out factories, right? Which is of course the holy grail, right? No humans, no lights on, just robots operating 24/7 with optimized throughput. And then there's everything in between, all the way over to a manual, let's say, unorganized, chaotic work environment with people moving things around. So
Definitely.
it's and that's actually what I think makes robotics so hard, right? Like there's no standardized environment, there's no standardized solution, and oftentimes in deployments, what I've seen is they end up becoming their own little science project, right? Because, in this factory floor, we need to interface with this elevator controller. And over here, it's like the conveyor belt is controlled by some archaic PLC. And, we can't open the garage door here because it has no API or, and so there's just so many things around it that, it's very, very different from building, a software as a service, for instance, where there are just after so many years, patterns and design and architectures that can be reused.
Mm. And I love like the lights out conversation too, like talking to like medical robotics teams who need like super clean, super safe environments where, no germs, no human interference
Yeah,
at all. It's
yeah.
like a whole nother conversation that's
Oh, yes.
really
Yes.
interesting. That when you think about like the hospitality industry or like the food industry now, they've got dark kitchens, right?
Yeah.
And it's
Yeah.
all a massive warehouse doing it. So it's really
Yeah.
interesting. Um,
It is.
and I guess with that, like a question that I kind of love to ask, like, you've been in this environment with software, hardware, but when people are building hardware, and it's a bit of a rogue question here, because like precision and reliability often comes to being one of the most important questions when you're putting things into production or selling something to a customer. But it's like a super tricky balance. Like, how do you approach precision with affordability? Like, what do you think of first? Like, where do you go? Where do you start?
Hmm. Oh, again, that's a very, very big question, right? And I personally think like it's very application specific, right? Like I said, we started out talking about here, we spent, I don't know, last 30, 50 years building robots and robotic applications following, targeting very high precision, high accuracy applications. And I think we've gotten so far that it's almost like with these new control systems, leave those kinds of applications as they are. We have a good working way of controlling robots and building those kind of applications. And maybe over time, newer learning-based control systems will be able to compete. Again, I haven't personally seen any data that compares the performance of a well-tuned motion planner in a classic robotic manufacturing cell with the performance of more vision-driven, learning-based control schemes. But it would be interesting to see, and maybe over time they can compete. For now, I think there's a whole class of, say the automotive industry, silicon manufacturing, those industries that are driven by takt times and throughput, and where whole production lines would basically get clogged up if something happens. I think, for now, let's just keep doing that the classical way, and then explore new applications with a need for higher variability, but where the consequences of a stop might not be as earth-shattering as in the automotive industry, right? And then you can build systems in there where humans can actually assist the robot, or bring them out of their error state. And I'm very, very excited about that. You mentioned the hospitality industry, the healthcare industry, things where humans are not replaced but are augmented by robots. I think that's what I'm super, super curious and excited to see, because these new paradigms almost have they could make robots, let's say, not more humans, but more human-like in their
Mm,
interaction pattern, right? Where regular workers or people can actually program or command robots in a much, much more natural way than what we are used to. And so I think that
definitely.
that whole new domain, which, is gonna really change robotics.
Yeah. And I'm definitely really excited to see kind of how it changes per industry and like per
Yeah.
use case application. Almost like, there's modular design, there's 3D printing, all these things that maybe didn't exist when this kind of first started. It was all very like manual to, yeah, like how we 3D printing components and changing things in that realm as well. It's like, I guess, the interesting trade-off we've spoken about from, classical to
Yeah.
modern
Yeah.
innovative robotics.
And it's
Um,
going to be interesting to see if robotics is going to go through the same hype cycle as 3D printing, right? Like, where 5 years ago, 3D printing was probably more of a tinkering hobby, and, then came along some of the big brands and have almost turned it into to a similar experience as 2D printing, right? And so if robotics gets there, where it's really just like buy a robot and tell it what to do, that would be a very, very cool future. But let's see.
Wouldn't it? Wouldn't it
Very,
just?
yeah.
And I know, like we kind of touched on at the very beginning, like, the computer vision, the VLAs, LLMs, all of that. So I know, like, AI is all the rage in robotics, right? It's a buzzword almost that we can't seem to escape. But like, let's also be realistic. Classical robotics isn't actually, it's not going to dissolve, it's not going to disappear. So talk to me a bit about how you see like classical methods still being so critical, even though we're integrating all these like novel and like sexy approaches.
Yeah, I think it ties back to what I said just a few minutes ago, right? That there are just applications that lend themselves better to a deterministic system, right? Where we know how the system is going to work, where stability is guaranteed, and where a failure is actually pretty critical for a situation that can end up costing you a lot of money. And then there's of course all the new, there's reinforcement learning, there's VLAs and VLMs, as you said, and I think I don't think I don't think they have to compete against each other. I think actually we'll end up in a situation where we need all of it, and where depending on the application, you have to almost like tune the knobs and say, I need this much of this one and this much of that one, and then figure out a way to say, okay, what's actually important in a specific application, right? And then you choose your weapon of choice, and then you build a system that works. Over time, maybe they may converge. Maybe we'll be able to cherry pick bits and pieces of those technologies and merge it into something that's better. I don't know yet, but it'll be fun to work in that space and see what can be achieved. But I agree with you. I don't see classical robotics, motion planning and control going away anytime soon, just because it is actually working every day in factories around the world. So that has to keep happening.
I definitely agree there as well that I don't think it's like we need two distinct toolkits and it's a trade-off between one or the other. I think it's we need to have that kind of merged approach and that kind of sweet spot between like something we know already works and then
Mm.
adding something in that's we slightly cutting edge but really has a realistic value application here. Like it's got to show its value and use case. But I guess for you, like, do you have any like specific examples? Like what comes to mind when you think of that? Either like that strong merge that maybe we haven't seen it too much yet, but there's any like cool examples you have there, or is there's anything that old school classical wise still that actually outperforms these like AI driven approaches?
Yeah, I think that without knowing for sure, right? I think like what we think of when we think robotics, auto manufacturing, transportation, say all the logistics space with mobile robots and AMRs, ATVs in warehouses, that there is really no alternative, right? Of course, they're starting to kind of be new approaches for learning-based navigation, learning-based obstacle recognition, and those kind of things. But at the end of the day, say mobile robots that are roaming around on a large factory floor, maybe multi-warehouse navigation, where it has to navigate to points it has never seen.
Mm.
We have perfectly well working solutions with say mapping and navigation, SLAM, those kind of things, right? And at the end of the day, they get the job done. So right there, I don't think there is an alternative yet, right? But of course, it's a very compelling thought that one day you can, like you saw it with iRobot and Roombas and the vacuum cleaners in our houses that are just roaming around randomly and creating a map, and all of a sudden it can actually plan really optimal cleaning trajectories. Of course, some of that could be ported over and be done like that, and it could learn kind of patterns of how people move around in warehouses, and don't go that way on Wednesdays because people are, I don't know, going there for lunch, so route the other way. So there are lots and lots of potential for applying learning in that space, but it's kind of right now it's at least sitting on top of the base navigation of I must bring this payload from A to B in the other where that is just needed, at least for consistency and predictability, right? Again, it's funny to see how predictability always ends up being such an important factor for factories deploying robots.
Oh, 100%. I think I remember, all the rage with all autonomous vehicles and autonomous driving and the sensor programs that are mapped into it, but then they couldn't tell the difference between, I don't know, a dog and a plastic bag. Or if you've got, an iRobot or a Roomba, whatever, roaming around your house and you've got a pet, like, those kind of path planning, but also predictability assessments are so important to make it super valuable as an application or like a product, right?
Yeah, I mean, again, predictability then we're back to the conversation about the lights out factory, right? Because it's then predictability might not be such a big deal, but oftentimes humans are kind of in the way for the robots. It's humans tend to learn patterns really quickly, and if they see a robot going like left in a roundabout or an intersection 99 times, they round up and say it's always going to do that, and then the 100th time they end up stepping in front of the robot and blaming the robot. So it's there's a little bit of a, I wouldn't say chicken or egg problem there, but humans and robots kind of interacting, not just being in the same space all the time, but actually working together is still kind of, I wouldn't say research, but there are early applications,
Work in progress.
specifically in say picking in warehouses or grocery shops or in the healthcare industry. So yeah,
Definitely really interesting. I think, if we put this as putting a human and a humanoid robot worker per se in a factory, what happens if, the robot falls over? It brings up so many other questions around like safety and reliability that
yeah,
we could probably go on for like quite a while on that. But I appreciate, look, we've touched on a lot so far today, but is there anything that I maybe haven't brought up that you think is so worth highlighting in today's chat?
uh, No, I think we touched on a lot of topics. As I said a couple of times, I'm super curious and excited to see hopefully robots being deployed in let's say maybe even less industrial settings and see them kind of just gaining tractions in applications that we haven't seen before. So it'll be a very, very interesting time, and a lot of interesting companies are gonna try and solve these problems, and hopefully we'll all pull in the same direction and create some robots that are really good for, let's say, mankind. Although that's a very lofty aspiration.
Very, very philosophical. But no, definitely. And I love that we kind of agree that whether it's like right now, like breakthroughs in the labs or like robots actually hitting the real world and even balancing, old school classical and these new like cutting edge methods that have been like really spinning out quite quickly. The last like years proved that I guess, it's not just here, but it's like right now and evolving at a
Yeah,
super, super fast pace. So I think for you, for me, but for anyone else watching this space as well, like the next year and so or so is going to be like a really exciting time.
yeah,
Um, so I guess I'd love to say like thank you so much for joining me today, Mads. It's been a real pleasure to have you on the podcast and it's been really awesome to chat. Yeah, it's been
yeah. Thank you
awesome.
for
So thank
having.
you so much for
Yeah,
being a
thank
guest.
you.